Hello and welcome everyone to today's presentation by Mezmo and D-Zone on telemetry data management, Tales from the Trenches. My name is Corey Knowles. I'm the managing editor of IT and business intelligence at Technology Advice, and I'll be your moderator today. We are excited to be joined by Bill Belnave, Braxton Johnson. Bill is VP of Technical Services for Mezmo, and Braxton is a solutions engineer at Mezmo. In today's talk, they'll be discussing how engineering teams can keep complex systems up and running smoothly. Just a quick little housekeeping note that we will have a Q&A session after the presentation. So as we're going along, feel free to drop questions right in the chat box there as they come to mind. That way we can have them queued up and ready to ask when the time comes. But now, please join me in welcoming Bill and Braxton.
Thanks, Corey. Hey, everybody. Very glad that you are here. Look forward to talking to you. So Braxton and I, as you can tell, we are down in the trenches. We're here. Okay, bad joke. Talk to you a little bit about telemetry data and how folks are using it to manage the health and performance of their ever increasingly complex application stack and applications. If you're an SRE, if you're responsible for enterprise monitoring, or even if you're a developer, you probably get a sense for a little bit of this and the struggle with having the right data in the right place at the right time to know when there's a problem or to be able to react quickly to it to mitigate anything that goes along with an outage, a little bit of downtime, all of that kind of good stuff. Just kind of looking at the poll that we asked you all to respond to, I always like to kind of get a feeling for where people are at from a knowledge perspective in terms of telemetry pipelines and using them and what they are. It's encouraging to see that there are a couple of folks that are actually using them, and more encouraging that most of you have at least heard of them and are curious to kind of understand what's going on. And you've, of course, come to the right place to do that. So let's go ahead and get started. So let me talk a little bit about maybe telemetry data itself first. And about a year ago, I had the opportunity to see a presentation by Greg Siegfried from Gartner. And so putting aside what you all may think of Gartner, whether you follow them, don't follow them, whatever, Greg's presentation was, I found it to just be really interesting. And there are sometimes you see a Gartner presentation and it feels kind of contrived. And then there are some where you look at it and there's a lot of honesty involved. And Greg has looked at, and Gartner last year hadn't picked up telemetry pipeline as a thing. Of course, observability wasn't all of that, but they were really looking into it. And Greg's been looking into it for a while, and he had a very kind of thoughtful presentation on it. And he basically started out by saying that telemetry data has been treated like the wastewater of our infrastructure and our applications. And if you think about, apps being the main product of the development process, the wastewater, the stuff that you don't need, that you basically pollute the earth with, that's all the junk that's being, quote unquote, junk that's being generated by developer logs, by infrastructure logs, by logs generated from libraries that you went out and grabbed off of open source and injected into your code. So there's a whole bunch of stuff, all of this stuff kind of being generated that folks really at the end of the day look at it with a kind of cursory glance and like, some of this is kind of important maybe, but I don't really get to take advantage of it. And I would submit to you that there's a lot more in here. And what we've learned is that there's gold in that wastewater, and it's worth looking into and spending time to figure out how to use properly. And so, but there are some things that go along with that, right? One of the things is the ever increasing volume of this stuff. And it's crazy to me kind of how quickly it grows. IDC talks about it being 23% year over year. I mean, I don't know about you, Braxton, but I feel like it's way more than that based on the folks that we talk to and the stuff that we've been seeing. In fact, we believe that the total volume of telemetry data being generated will surpass the total volume of business intelligence data being generated and used by next year, which to me makes telemetry data then even really more interesting And I think the other side of it is that with this growth in volume, like people still have to do things with it. They've got to figure out how to deal with it. And amazing to me that I heard a stat from another stat from IDC that I didn't put on the slide, and that in 2023, observability and use of telemetry data represented about 10 to 20% of the overall infrastructure budget on average for most organizations. To me, that's huge. That's crazy, and it makes it a first-class citizen. And so then you would think, well, with all of this data, certainly resolving and preventing application issues and issues in the infrastructure and stack should be a piece of cake, right? Like it's all at our fingertips. What's more interesting, though, is that survey that the DevOps Pulse did last year showed that 70% of the people that responded still spend multiple hours resolving application downtime. So, all of this water and not a drop to drink kind of thing. It's like, what's going on, and why is that such a problem? Why is it such a problem? Well, a lot of it has to do with the nature of the telemetry data itself. But we looked at the conversations that we had with our customers over the last year and did a little bit of categorizing and analysis, and maybe applied a little chat GPT to categorize and things like that. But what fell out was really, I feel like, reflective, especially of the direct customer conversations that I had, which is like the biggest issue is just the sheer volume, and coupled with that, the quality of that data. And by quality, not to say that it's necessarily bad data, it's just not always well formatted. Formats are inconsistent. Formats change from time to time. The stuff that you really want can be packed densely into a really long string of text, and so there's parsing. There's a whole bunch of things that need to happen to make that data useful, and a lot of organizations just kind of throw up their hands and like, man, it's just too much work to get to that. On top of that, there are lots of tools that folks are stringing together, and like I see our customers have either gone all in on an observability stack, a Datadog or a Splunk, and then they're complaining about the cost and what can they do about it, or they're cobbling things together, a combination of OTel and other kind of open source things, and maybe a little bit of a log management or observability tool or multiple observability tools and all those kinds of things. And so that kind of adds to the struggle as well. And then kind of following that up, like, oh, there's a bunch of stuff in there that I didn't necessarily want to be in there, and I don't always catch it, and I've got to figure all of that out. And all of that leads to just making troubleshooting and operational efficiency really difficult to do. So, looking at all of this, I think we have distilled this down into really kind of three main issues. And the first of those is, and I think this is potentially surprising to some, it's just that flat out, like, most folks don't really know what's in there. Always basic idea, cursory idea. But the fact of the matter is that what's in telemetry data, especially in log data and in traces even, it tends to change on a fairly regular basis. We may have an idea of what's in there, but we don't necessarily understand the format. We don't know what else is in there. And as you think about building out and developing code on, say, or developing apps on microservices and layers of infrastructure, there's a lot of different points where telemetry data is being generated, and most of those points you don't necessarily have any kind of control over. You're using them, and other things you're embedding and all of that. So at the end of the day, it's not really surprising that you don't necessarily know what's going to be in there, or what's in there, or when it changes. Expecting one thing and getting another, and things like that. That represents a huge problem. And typically what we see, it's the biggest problem. The next thing is, well, there's just a ton of it, and maybe I don't need all of it. Maybe I need a small portion of it. I tell a story of a lot of this year of talking to a customer who essentially was taking everything from all of their logs from Cloudflare and dumping it into a very expensive high index storage. And a lot of it was just kind of info lines and things like that. But when I talked to him about it, he said, look, I have no idea when I might actually need this stuff. And I can't think of a better way of dealing with the problem. Like I've got to have it at the ready when I need it. When I don't need it, like I really don't need it. But it's essentially an insurance policy. And I feel like a lot of folks are essentially doing that. Like it's this big insurance policy. I'm dumping all of this stuff aside and I'm paying a lot for it. And there's a lot of stuff in there. And when it comes time then to actually use it, now I've got to wade through all of that data to figure it out because it's not always in the format that I need and all of that. So there's a lot of kind of just lack of optimization of this stuff or getting it in the right format in the right way to make it easy to use. And then, finally, there's this, what I'll call kind of lack of agility or potentially maybe lack of responsiveness. And it's responsiveness on a couple of different levels. Like I said, the data is changing on a fairly regular basis. The value of that data is temporal. Sometimes I need it, sometimes I don't need it. I want it, I don't want it, all of those kinds of things. And like there can be external conditions that change my need for it, as well as internal conditions and change in the data. And I just can't adjust to really get things tuned the way that I want them to. And so as people think about solving this problem, there are really kind of three ways that people are going at it. And the first two kind of represent the majority of folks. This one, I don't see a lot of folks doing this that much anymore. But at the end of the day, like this is the simplest and the cheapest way to take advantage of telemetry data. I'm essentially pulling data out of my various layers, and I have the ability to look at it in the context of that layer. If I want to essentially correlate or understand what's going on in the whole stack to better solve problems, that's kind of hard to do. So problems at an individual layer, I can knock those off, or situations, whatever, at an individual layer, I can deal with that. When I've got to go and correlate because I'm not really sure, like lots of warnings going off and people pointing fingers, it's the old school getting into a room with logs and everybody kind of figuring out, okay, what happened at this point in time, and what's the root cause, and obviously like tremendously complicated. And then so people spend a little bit more money and they're like, well, look, the solution is to put it in one place, purpose built to handle it and do that correlation so that I can get faster to what's going on, get ahead of it, minimize downtime, or prevent any kind of quote unquote outage, things like that. And like I think this is how most people solve the problem. But at the end of the day, those same people, I feel, are really starting to feel the pressure that I was talking about earlier of like, this thing costs a lot, and and the price is continuing to go up and up. I've had some folks that I've talked to talk about 5-figure overages from their current observability tool in a given month for lots of reasons, like because all of a sudden data started going in and they didn't realize it more than they had expected, because the way these things are licensed and set up, like it's ridiculous and it doesn't make it easy to use. There's all of those things. And so now I got lots of data that I've got to try to weed through, which, I can correlate, but I still got to weed through all that data. It's really expensive. And the other thing that's started to happen, quite honestly, is like there are now different parties interested in this telemetry data. It's not just for resolving problems anymore, right? It's not just for SREs. It's not just for devs. And so, but those different consumers, of course, want to see the data in a different way. They want to take different cuts at it. They want different parts of it and all of that. And so now if I'm dumping everything into an observability tool, it's not purpose built for those other consumers. And so this is why folks really got interested in this notion of telemetry pipelines. And what is it? It's essentially a conduit that allows me to pick up data in motion from lots of different sources, pull it all together, do things with it, wrangle, enrich, normalize, a whole bunch of stuff while that data is still in motion, reformat, and then deliver it to potentially lots of different consumers, given what those consumers need and how they work with it and all of that kind of stuff. So I've heard people compare it to ETL, and I would tell you that at a very cursory level, like I shrug and kind of like, yeah, maybe. But with most ETL tools, the source data is fairly well known and it's fairly well structured, and I can, it's at rest, and I can pick it up when I need to, and I can drop it off to another fairly well known destination that is also at rest. And with telemetry pipelines, that's not the case because the data is in motion. It's constantly being generated. Its relevance is very temporal. And because it's in motion, my ability to do things with it is limited to that time period that it's going and all of those kinds of things. So all of those layers of complexity make this kind of really interesting and potentially tricky to deal with. And so with that, I want to segue for a minute and talk a little bit about how do you address this from an architectural perspective. And Braxton and I were talking about it, and we know a lot of folks that are looking at OTel, using OTel, and kind of shrugging. They're like, "Yep, we've got what we need. We can get away with it." And you get into conversations, and it's like, okay, the more sources you add, the more OTel collectors that you need, and then those OTel collectors need collectors, and then those collectors need collectors, and all of a sudden you've got a telemetry pipeline or a observability data infrastructure that matches the complexity and ugliness of the application stack that you're trying to monitor and manage and all of that. And like that ends up being maybe not so bueno either, and really not a solution to the problem. And like we talk about having a much more hybrid approach to it, and this actually is working very well for customers of all different sizes. And we've got customers that are up to a petabyte a month or more, and some that are 50 10 gig a day or 20 gig a day or whatever. And like this services all of that. And so the good news here is that we give people the ability to ramp up. There's room to grow, like the true promise of the cloud, which is I can scale up and I can scale down, and there isn't a lot of work that I have to do to account for that scaling. And the way that we set it up essentially is this: like for us, a data source is a data source, and we've got an agent, but maybe there's maybe using hotels or anything else. Like there's a whole bunch of ways to get data in. We think about a hybrid approach to pipelines. So when I talk about edge processing, like you see here in the slide, like this isn't just a connector. This is actually kind of a mini lightweight pipeline where I can do a little bit of processing. Maybe I redact my PII data out there. Maybe there are some local destinations that I want to be able to serve where like that data never needs to never want that data to egress out of my network or whatever that happens to be. Like I can service those things there, but then you want to be able to leverage the power of our cloud in a much larger situation where we can provide durability and we can process things at a much greater rate without all of that complexity, and then still service all of the needs of those various destinations. And we think in order to kind of provide that scalability and be able to adjust as things change and grow and all of that, like this is really the best way to look at things. So given kind of all of that background of like, here's what's going on with telemetry data and all of that, like, let's maybe get into some specific examples. So now let's get down into the trenches. Let's bring up some product and talk through certain scenarios. And I talked about kind of the three issues earlier of like really not being able to understand what's in my telemetry data, the volume of that data being too much, so it's difficult to optimize, and then I couldn't be very agile with it because of the nature of that data and all that. So we want to address those three things head on. And Braxton is going to walk us through, and I'll ask him a bunch of hard questions and hope that you all ask questions as well. And feel free to do that. And if you pop questions in to the window, like I'm kind of monitoring, so we can always pause and answer if you want us to. But we'll dive into this stuff and we'll look first at like, how do you appropriately, like, what's a practical way to look at what's in my telemetry data so I can get a handle on the volume? And then two, how do I transform it to make it practical, usable while in motion and be able to serve all of these various destinations? And then three, how do I adjust in this rapidly changing world to both internal and external factors to be able to, still get what I need out of this telemetry data and just adjust based on what's going on externally or what's going on internally. So with that, Braxton, please come off mute. You've been way too quiet, man. You're supposed to be bugging me and asking me hard stuff. So come on out and let's get into the trenches and really kind of go through this stuff practically.
Yeah. So one thing to note before we jump into the product, this understand motion that we have right here. Let's see if I can jump to the slide that we were just on. When you're talking about taming data volumes and understanding, it goes back to that architecture slide that Bill just brought up, where you have a situation where you have open telemetry collectors, you have agents, all these things on the edge that scale out, and you have to understand what's coming through there. What does this actual architecture look like? And when you're doing that at enterprise scale, managing 1,000 different YAMLs for 1,000 different servers to bring things in becomes incredibly complex and slows teams down very quickly. So one of the first places where Mezmo steps in is that understand motion at a high level of what's going on in my telemetry pipeline system, as well as at a low level of what data is in there. So I'm going to jump into the platform right now, and we're going to walk through and show you what this actually looks like. So let me share my screen, make sure that we're all able to see. All right. Bill, you able to see? We should be in a system overview.
Yeah, we're in
awesome.
Good shape, I think.
Okay. So what we have right here is the first high-level view of the Mezmo platform. This is an overview of the different telemetry pipelines I have set up, of the different sources, of the different data that's streaming through, so I can have an understanding of what is my throughput, where may there be issues, and really get a handle on, at a high level, that 30,000-foot view of what does my telemetry architecture look like. From here, you're able to dig into things like sources and destinations and that. But this is really just that first high-level management view. When we really get into understanding where Mezmo begins to bring in quite a different approach to how people handle telemetry data, we actually start with understanding your data. We call this data profiling, which means I'm going to go in, I'm going to look at my data stream as it comes through, and I'm going to pull out the different patterns, my heavy hitters and things like that. What this looks like is something akin to here. This is a telemetry stream we have coming in from a bunch of supercomputer logs that are running some complex calculations on the back end. And we have this live stream flowing through. The first thing that Mezmo platform has done is pulled out what are my unique patterns? What is the data that I have within here? This area in particular is a great starting point for both developers, for SREs to have that shared conversation with their developer team and understand, what can I tap into? What metrics may I want to pull out? What signals are either noisy, should be rolled up in some other way? This platform allows you to begin exploring, what is my heavy hitters on the apps? What kind of levels do I have coming through, and begin to break this data down on the different slices of your data to really get an understanding of what is coming in when it comes to these custom application logs. Businesses that we've been working with, they've all got different business needs. They've maybe using a telemetry stack or a technology stack that is familiar, but then they've added on for their own business context, unique use cases, unique information. They've injected their own logs and even built out completely custom systems, which from both a large enterprise scale where you have siloed teams working on different pieces, as well as onboarding new users, how am I supposed to understand what I have access to, what I'm able to tap into to monitor, to understand my data and really get value as that volume increases, as things start to explode? It's heavily tied to the value of that data. As you go through there, the volume's okay if you're getting value out of it. This is really where you dig in to understand what that looks like. As we go through, you're able to begin to apply different processors and automatically generate a pipeline based on these profiles to say, hey, maybe I want to filter out these generation logs, or maybe I want to sample or throttle or dedupe different pieces of these and apply these processors directly in stream to my data so I can begin to take advantage of them. When you,
I was just going to say, like, as you're going through this, like, we're not really, I mean, there's no magic here, right? Like, there's no AI in the background where we're like telling you what to do. Like, you're looking at this with the eye of, like, I've got a baseline understanding of the applications, or I can look at the patterns and determine like what the value of that pattern is. And if I need to do more kind of investigation, you can do that as well, right?
Absolutely. AI is such a charged word in the telemetry space these days, it seems. And there is a piece on the back end where we're using machine learning and some data analytics to go through and determine and cluster what are these patterns that I have? What is the data that's in here? But really, this is an intelligent lens that we provide to the users, because at the end of the day, when you're dealing with custom applications, when you're dealing with custom business logic, you need your tribal knowledge. You need to be able to have that conversation with your developers, your SREs, to know, is this something I care about, or is it something that I don't care about? Is this something we can take value out of and dump it into something like a Grafana or a database or data lake or wherever we may need this data? Or really, is this just fluff unless there's a situation or incident in certain circumstances? And so what this provides is a good view, but it's a starting conversation, either for you as a developer who has that domain knowledge and understands, okay, I know what is actually being pulled out of this symbolic link log right here, or what is the value for my part of the business, or is it a SRE going in to try and determine what are my SLIs and SLOs I want to actually measure against. I now know what pieces I should begin asking the developers about. I can ask them, okay, Steve, what is it that you were trying to get out of here? What is the value? If we were to filter this out, is that going to be an issue? Is there something better that can be done? Without being able to see a view into your data like this, that conversation is incredibly hard. It requires, yeah, it requires hours of meetings, conversation, digging in, understanding the stack, where this short circuits that quite incredibly. So once I've taken my own domain knowledge, my tribal knowledge, I understand what I should be applying here. We can then apply these processors into a telemetry pipeline. And so here you can see that we're starting to filter out the double hammer, we're filtering out the generation, and quickly inserted in stream. These profiles are able to lend you the ability to start to slice and dice, be able to understand your data, and then begin to apply optimizations, transformations, things that you can begin to make that that data more valuable. Because at the end of the day, there's absolutely a cost issue from an enterprise and organization. Developers and SREs, they care about the value. They want to know that this data is something that I'm going to be able to get access to. That's something that I'm able to monitor against. And when something breaks or goes wrong in my system, I have a signal into there and I have a place to look. It may not happen all the time, but that safety net is incredibly important from an enterprise developer standpoint.
As you think about this profiling exercise, like, is it a one-time thing? Like, how often you do it? Like, how does that work?
Absolutely not. So fundamentally, data engineering is kind of an overlap here with what we're talking about, and that practice is a constant cyclic cycle. I guess that's both the same word, but regardless,
Nice.
you go in, you first want to understand what you have at your fingertips. You begin to apply transformations, processors, filtering, transform the schema from A to B, normalize, standardize that data. You get a good baseline. You then get it downstream. And as your business evolves, as you inevitably begin to introduce new features, begin to say, hey, we weren't watching this part of our Substack, but we actually need to. You go back to this understand motion. You begin to run a new profile. You can grab it at different parts of the day for different time windows, for different, whether it's a Monday, whether you want to check things at the end of the day when you're running a bunch of cron jobs or earlier. All those are questions you want to ask. And this is that first starting point. This is the place where I go in, I run, I profile, I understand, I begin to apply things. And either the same day I go back and tweak it more and further optimize, or you can come back, a month later when you've realized, perhaps your networking interfaces need to be a little bit more, you need some more detailed, you need some enrichment, you need some additional things. You go here and you look to see what's there to begin with and what you can begin to change.
And you made, it's part of the pipeline too. At least that's what it looked like when you'd done it before. So like I can potentially have a lot of flexibility in terms of like just profiling like an app or filter down or sample or like, yeah. So there's a tremendous amount of flexibility in how this has been implemented in the platform itself.
Yes. The way I think of the profiler is it's a scalpel. It's an intelligent scalpel that gives you insight into your data. And you may want to do that at a full level of all my custom applications, my network data, my logs, metric trace, all the things coming through. And that's a great first starting step. but oftentimes you need a little more detail. You're really going in and dealing with maybe some subcomponents. You're dealing with the front end servers, or perhaps you're dealing with the back end customer databases and your server, how it pulls out information. When you do that, you can go in and very quickly slice your data down, figure out which part and aspect you want to apply, and then you can apply these profilers at any point during that data. So you get it at a high level, you can get it as granular as you like, and the more granular you get, the more a view like this becomes applicable to the situation that you're detailing, that you're looking into.
Yeah.
I see a question in the
Yeah. So we
Q&A.
just got a quick question from
Yeah.
Arvin, and thanks, Arvin, for the question. So you're asking, like, after data profiling, if I select a particular pattern, do I still need to pay an ingestion cost? It's I won't bore you with all of how we do licensing and subscription and things like that. But it would suffice it to say, like, in most instances of using Mezmo, you would actually not be paying for that. At that point, the way we look at licensing things, a lot of the way that we look at licensing has to do with what you're retaining and indexing and how many destinations and things like that. So that's kind of one of the benefits of it. And, we want to encourage you putting as much data through the platform as possible. So, yeah, hopefully that answers your question. If it doesn't, like, put more in, we can keep going on this topic.
One thing to
make me call a sales guy, because I don't want to.
One thing to note there on the cost piece, a lot of these downstream destinations, the high-end platforms that you may be taking advantage of, whether it's Datadog, whether it's Splunk or Grafana, their model is kind of like what you're hinting at here, where you send the data in and you pay for everything that you'd want to dump.
You got to get the data in before you can actually use it, right?
Right.
Yeah.
Exactly.
And our point is, like, only put in the data that's going to be useful and what you really need. Yeah, exactly.
Exactly. Fully tied to the value. So that way you can, because oftentimes telemetry data is incredibly noisy and does have a lot of excess information. You shouldn't be paying for that if there's no value in it. And we very much fall in line with that same view.
Yep. Yeah. Good.
Now,
get to more of the good stuff. I keep interrupting you.
It's okay. Now, there is quite a bit more we can kind of dig into on the profiling, but that next step in that cycle we were talking about, first understand, then I want to start to optimize this data and then decide where I want to send it or what I want to do. Our next piece is that optimization. So how is it that Mezmo can actually not just filter and sample down logs, but how can I start to pull out more information? How can I really turn this noisy log message, perhaps it's a health check, perhaps it's Apache logs coming through, and it's something I can take value out of as a business at a cost that makes sense. The way we do that is through the actual processing that you have within pipeline. So I'm going to jump forward using this same data set. We're going to go into a pipeline that's been built out a little more complex, that's pulling out things like metrics from your events, that's normalizing some of this data as it goes through, sampling, throttling it, and generating alerts and different pieces to be able to get that data into, in this case, Datadog. But we can showcase how it's able to get into really any platform, whether it's something like a Prometheus or an App Dynamics. Ram, before we jump into there, I do want to just touch on your question that you had here. So he asked, how does this compare to other tools, frameworks such as App Dynamics or Grafana? I don't really see this as a direct comparison. Where we fit in is an augmentation for these tools. We're not looking to replace your APM with your App Dynamics or your monitoring solution you have in Grafana and the amazing dashboards you can build out of there. What we are doing is enabling you to get that data so it's correlated right, so it's enriched properly, so it's in the right format, so you can get the value out of it at the cost you need when you dump it into your APM or when you dump it into your metrics platform.
Yeah, apologies. I meant to make that point earlier when I was talking about that slide with telemetry pipelines. Like, yeah, we don't want to replace what you're already using. We want to help you. Like, if you love it, we want you to love it more and not have to pay too much for it. Essentially, is what it comes down to. And then Nikolay, I'll just follow up. Like, what is the technology stack behind Mezmo? So we actually built on top of the Vector open source project, and we've been contributing to that. Although we're now also starting to incorporate some OTel stuff and look at contributing to that project as well.
One of the big pieces, the stack and the pieces that we're using underneath the platform are incredibly powerful to a certain extent, The problem that you get to with a lot of those kind of tools, though, is how do I scale this out if I'm dealing with petabytes of ingestion, if I'm dealing with multiple terabytes coming through? That problem is extremely tricky to make sure you have the durability, the caching, the buffering. There's pieces built into our platform where we extend out, where you send in data, we don't drop data as a fundamental principle. Once it's in, you have a cache, a durable buffer that if there are issues downstream, we can replay that through, resend it, and ensure that in the end, your data makes it to where it actually matters. So you don't have this kind of a brittle sort of YAML file cobbled together to be able to define what's going on. What you get is a very intuitive, and I probably should have, there we go, way to define what are these telemetry flows. So I'm going to stop for a second talking about the profiling of that. And let's just talk about what a telemetry pipeline looks like in Mezmo. What are the components? What's going on here? And what the heck are you even looking at? So first thing you're able to see is you get some insight into total egress, ingress coming through, where those things are going, how that flow of data has been over the last short period. Beyond this, you're then able to define different sources. And what you can think of this as a flow graph. You have data coming in on the left for any number of sources. They then move through this pipeline. You can kind of see this dot flowing through into the different processors, into the different steps to begin to apply the transformations you need, the slices you need to really manipulate that data the way you want. This can be where you insert a profiler to say, hey, this piece of the data I need to understand further. Or this is where you insert things like, I want to throttle certain pieces of this data, or I need to turn this very noisy log message into a metric I can watch downstream in my observability platform. And so as you go through, and if we go into the edit pipeline piece, you can see your sources that you set up. We'll grab from OpenTelemetry, we'll grab from Splunk, we'll grab from your Logstash or your Kafka, or really anywhere that you're sending in telemetry data, because this ecosystem that people tap into, it's very complex, it's very large, it's something that's been around for decades. And so you have lots of different protocols, lots of different ways that legacy systems may be able to kick in data. Wrangling and managing that, it shouldn't be your company's job. That's kind of the conversation of context first core. And so we want to make this as simple and easy as possible to tap into any of these systems. From here, as I begin to define what are my different flows, or how is this data be connected, I then go into my processors, and this is where we get into the optimization piece. And so as I look at different slices of my data, and I'm going to jump back in just a second to the profiler to kind of talk about two examples that we pull out here. But this is the tools that you get within the Mezmo platform. We'll deal with reduction, so you don't have to worry about how do I do a map reduce at scale for data in stream? How do I sample out data? How do I route it? How do I convert it from, let's say, a log into a metric, or from OpenTelemetry into what's needed for Prometheus? All these things are built into the platform so I can quickly parse my data. I can quickly be able to get value. But not just that, I'm not limited to just this visual interface, just these pieces that we provide. It is all fully backed by code, meaning Terraform, to be able to define how these things go through. And you also get scripting. So for those complex problems, when you're really dealing with the developer, very often what I want is to be able to code, right? And so I can go in and I can define JavaScript on these event streams and be able to say, okay, I may not need to do something as simple as just mapping or rearranging the structure or parsing out, the syslog message to be able to get the latency that's buried in there. But I want to do something more complex, like calculate a running average, or be able to, there's one pretty interesting use case we had with a customer. So essentially a national airline that we work with has a whole bunch of ticketing information buried in their system. So they let you know, when is a flight booked? Where was it booked at? With which kiosk? Which person actually helped them? This system, though, is connected up in quite a bit of old legacy systems. And as they try to deal with network issues or any of that, they tend to double up and send this data through multiple times. And so you have this big deduplication problem where if you think about an airline, you're dealing with thousands and thousands of flights per day at hundreds of different locations across the nation. How am I supposed to be able to understand that Carl grabbed 2 tickets by accident and we're charging him twice, or he's booked with Susan's seat and now there's going to be a problem when he gets to the gate? Telemetry pipeline lets you go in, pull out those things, and then able to deduplicate this information in stream using something like our D2 processor. And not just that, they're able to then go and take this information, put it in a schema that matters, and get it into a monitoring system so that they can get flagged and alerted on this information when it's an issue, rather than waiting for Carl to show up and get into a fight with Susan on the plane when he tries to sit in her seat. So there's a lot of different ways that, not just from what you would normally think of, like, is my system up with the infrastructure, but what business value can I derive from this, and how can we enable our support staff and different individuals to get value out of this? Now, this has a few things going on here, but I'm going to back up to the profiler so we can give a little context of what it is that we're actually pulling out of here. So as we look at this profile, we've got a generation message, which is like, hey, we're generating spinning up a new core, or we've got these different exceptions and errors and pieces that are going through. In my telemetry pipeline, what I'm doing here is I'm actually first slicing on those profiles that have been determined, the generation core. So for this one, I'm going to go in and I'm going to run a script that uses a little bit of grok magic and pulls out what the core value is, puts it into a field, something that's machine readable, and reduces that, meaning, let me aggregate it over 5 minutes. Let me just get all of the unique cores I have coming through here. Let me get all of the different pieces and components. Beyond just this, though, we also had things with our errors. So we had, if you go back here, there's an illegal instruction one that pops up. And for this particular data, it's highly important that we know when that happens. And so I'm able to use our, in this case, it's a processor group. We're able to use our processors to identify that this is an error and pull it out. And then dump this into a notification channel, in this case, a Slack channel or a PagerDuty or any downstream system to be able to get value. But backing up, I want to dig in just for a second on this processor group, because it's a place where it really allows the telemetry pipeline to scale out for an enterprise. What we mean when we say a processor group, you can think of it as just reusable logic for an organization. So if I'm going in defining SLIs, or if I'm taking, Apache data and turning that into a metric and putting it downstream, there's not just one place you want to apply that. There's usually many different places throughout the organization that you want to apply that. And perhaps you have to go and loop with the proper developer team or the proper SRE team, and it takes time for you to know that you should even be doing this. A processor group allows you to define many different processors in stream, get as complex as you want, and then package this up in a reusable way that the rest of your team can then take advantage of. So in this case, we're very simply just filtering down on what is the message coming through. Is it the illegal instruction one that I care about? I'm then, again, aggregating this over 5 minutes. So let me get the total number that I had in that period. And then we're kicking out an alert when that's above some threshold I've defined, when it's above, 1,000 of these coming through, or a certain percentage of my data coming through. I now care, and I want to send that out. This piece, while it's useful here, becomes very useful once you begin to apply that across your different stacks as you get more generically. A couple of the other pieces that pull out and worth noting, I believe, is this throttling and sampling of your data. It's a very simple way to help reduce down that data. And in many cases, you don't need all of your info logs. You don't need all of your debug logs. You just want to have a small signal into it. Or you don't need, unknown data coming through. And I want to have a certain throttle or threshold that I'm saying, we don't need more than 50 megabytes of this per second, or a certain number of data coming through. Very quickly, you can add these on and then begin to control that data, be able to wrangle it down, and get to a place where instead of bringing in 600 megabytes of data over the last 3 hours, I'm only really pumping out 30 megabytes. You're only taking value out of what you care about, and you're getting rid of all the chaff. Now, there's a piece where this plays into, and it's kind of a what do I do next kind of a question. How do I respond to this data? Because I'm sure as a past developer in a past life, and as many of you know, not every single situation is going to be the same. If I am in a normal mode, if all my things are operating, yeah, I don't need all of these info logs. I don't need all these debug logs. I'm okay aggregating and rolling, a metric up over 5 minutes or 10 minutes or getting a 30-minute fidelity. But when everything is on fire, I actually do care about what's going on. I actually do care that the system is got all this extra information, that has got the context of what's going on. And so you can see that we just flipped to incident mode. What this is this is the responsive piece of a telemetry pipeline. You're able to take logic and define, using a scalpel, what you want to do under these different circumstances. So in this case, we have an incident defined. We've actually watching in stream in the pipeline, looking to see how many error events do I have coming through. If it's above a threshold I care about, let me say that there's a problem. Let me turn it on to instant mode. And downstream, at each of these processors at each step, you then can make a decision. Do I want to actually sample, or do I really want to skip and bypass and grab full fidelity when I'm in instant mode? Same thing with the throttling, same thing with reducing or aggregating. Any piece of this, you're able to make a decision and say, maybe I do want full fidelity, or maybe it's not that you want full fidelity. Maybe you want to enrich with different context, or maybe you want to route that information into a different observability tool under those cases, because now your security team's going to have to go in and review, and they need to make sure that that particular information is in the tool they care about, or the data lake that they're going to be pulling from. All of these decisions are up to the user, up to the company, to make sure that it's applicable for their use case, for their business need. Now, I think that visually we can see that's in instant mode, but it's kind of hard to understand what the heck this even looks like, or what's the end result. So I'm going to pump into Datadog really quick and show you what this incident mode actually looks like. What the heck are we even talking about? Because we've taken all of our data, we're normalizing it for Datadog and putting it in there. But let's see what this looks like. So before, we had a normal mode, we're grabbing a small subset, and then when we're in incident, we grab everything. So I'm going to show you two versions of Datadog. One, if you don't implement something like a Mezmo, so you grab all the data, you put everything in, and when you do that, you end up with quite a bit of information. You've got more than half is your info logs. You've got a whole bunch of context, and because there was an incident right now, there was an issue, your developers may not care about going back and checking out this data, or even need it, and so then the business is paying for something that you'll never touch. When you introduce something like a Mezmo pipeline, those decisions, that responsive behavior, whether it's triggered within the Mezmo platform or by your incident management system like a Datadog or Grafana, then becomes much more narrowed down, and you get rid of that signal to noise problem. And what you end up with is a view that's more like akin to this. So in this case, this is the exact same data stream coming through. We just took one path going straight to Datadog, one with that system you just saw. And as you can see, when we have a spike of errors, when there's an issue, I do begin to grab all of my info logs. I grab all of my context and information on there, up to 5 minutes, 30 minutes, an hour, whatever makes sense for the business in that case. I capture all of it, and then I turn it back off. This allows me to really optimize my usage of Datadog and make sure that when there's an issue, when there's an incident, my team has the data and the context that they need to get value out of it, but the team's not paying for that, on a Sunday night when there is no issue, or for the past 2 months when there hasn't been a 7-1 issue. You can capture whatever it is that you need. This optimized cost really allows you to go in and identify what is the problem, what is the issue that is at play here. Now I want to be cognizant of enough time to be able to do a Q&A in the last little bit. There's one flip side of this that I think is worth digging into and just briefly mentioning. This is great that you're able to capture the data that you need under the situation you need. But as we all know, incident management systems do not always have 100% accuracy. Sometimes there may be a problem that pops up that you don't find out about for a month until a customer support call gets surfaced and escalated up to the engineering team. And now you have to go back to look at data, or perhaps you see that this occurred, this spike, but your decisions that you made in the pipeline were not granular enough. What you can do is Mezmo has a holistic way to archive and replay data. So very simply, and you can see here, this is that same EGL data stream with a different pipeline, connected up, and we're dumping into the Mezmo archive destination. All this data gets sent into low-cost storage that you choose, whether it's AWS, whether it's Azure. You're able to ensure that you have access to that for 30 days, 3 months, 6 months, whatever makes sense for your team. But then on the flip side, when you decide that there is an issue and maybe you needed some more context, maybe it stopped capturing everything here, but really you need to dig into this window here, I can then use the Mezmo platform to go in, grab that data, funnel it back through, apply different transformations, processors, enrich the data, or even just do a straight pass through and get it back into a system like a Grafana or a Splunk or a Datadog. So you have access to that. And so you can get value. So it's, to me, I see the archiving and rehydration as the safety net to a data optimization strategy. So with that, I think that.
Nice job, by the way, man. Like you, it's good.
So I'll pass it off and stop to share unless there's any more. I haven't watched the Q&A quite as much as I should.
No, there weren't any
okay.
that came up there. Like maybe let's leave in product, and because if folks have questions about product, I want to be able to.
Yeah, happy to.
Yeah, so let's open it up. Oh, and you're on
Corey,
mute.
I think you're on mute.
Oh, no.
There
Can you hear me?
Got you now, brother.
Cool. Thanks so much for the presentation. We do have a couple questions already here to get us rolling. What are the best practices for implementing real-time actionable alerts to improve overall operational efficiency?
Go ahead, Braxton. I may add on to that if.
Yeah. So I think one of the biggest pieces for proper alerting is to understand what it is you're even alerting on. What is the signal that you care about? So starting in a place like a profiling to be able to know what signals I want to pull out is important. But beyond just that, you don't always want to be tied into alerting on your downstream observability system. As we're discussing this kind of a paradigm, you're making decisions to pass in data to certain places, to pass in data to other systems or into your archiving. So that downstream system may not always have the ability to have the context to alert on. What Mezmo introduces is in-stream alerting, meaning that with this data as it flows through, you're able to very quickly action on that data, notify individuals whether or not this data is just going into a data lake for your engineering team to be able to get value out of, whether this is going into, a ticket management. We have the ability to be very generic with our webhooks, so you can talk to a Jira ticketing system, I get a PagerDuty, but all of this before you've had to pay to index it, before you have had to wait for the downstream tool to roll that information up, to process it, and then to make a decision and notify somebody. So this really allows you to get much more agile, much quicker, reduce that MTTR. But I think the fundamental one is understanding what it is you even want to alert on. What is the situation? What is the cases? So going back to that profiling aspect.
Yeah, and I think I would add on to that. Like most people, I think of alerting after the fact, right? So I've got to get the data into my observability tool, then I can do alerting on it. We're like why would you waste your time doing that? There are people that are dumping, just gigabytes of data in just for the simple fact of doing an alert. For us, the best practice is do that in motion. Like whittle all of that data down to the salient point that you're trying to alert on, the metric or whatever, and derive or drive the alert from there, as opposed to having to dump all of that stuff into expensive storage and then figure out how to alert on it.
That makes a lot of sense. We have one more here. What are the best ways to scale telemetry pipelines for organizations with rapidly growing and evolving microservices architectures?
So my view on this one is kind of two pieces. One, take advantage of the scale of SaaS. When you start to introduce many different systems, many different uses, if you're building out your own telemetry pipeline, you have to begin to worry about, how do I cache this data? How do I buffer it? How do I ensure that there's consistency between the different nodes of the system? It becomes extremely complex as you introduce many different services like you get in a microservice architecture. The other piece of that is to use a consistent nomenclature and integration path. So if you're in a position where you can make a decision as an organization, take advantage of open telemetry, for instance, as a way to instrument your logs, your metrics, your traces, that allows you to very quickly tap into the stream and scale it out. Oftentimes, that's not always the case. You may have teams who, the new stack is using OpenTelemetry, you got Fluent Bit in there, you got syslog coming through. So there's a way to meet you when you use your telemetry pipeline. But making that decision as an organization that we're going to take this path and this is how we're going to standardize to be able to get this data in, it's a big one up. Short of that, when you don't, you're dumping everything into your telemetry pipeline, one of that first pass of the profiling should be to standardize and normalize your data as an organization, to make sure that if things are coming in, you have 30 different log formats and you have 20 different ways to describe a environment, like the developer environment or stage environment. clean that up, make sure that you implement ways that you're able to reduce that down. So the correlation when you get downstream is much simpler, is something that is not noisy, and is something that you can follow the direct path back to understand what the issue was to begin with. I'm not sure if I missed anything there, Bill. Anything to?
No, I think that was pretty thorough. Yeah, thanks.
We have another one we just got in here as well. Datadog offers configuration to decide what to index and rest to go into archive, like cheap storage. Why would I put Mezmo in the middle? Is Mezmo like an hotel collector on steroids?
So look, Arvin, I would say to you, like, if Datadog is the only thing you ever have to worry about in terms of where your telemetry data goes, if it's the only source, then yeah, maybe you don't necessarily need Mezmo. I would suggest to you that's probably typically not the case. And like what we see, and I'll give you a specific customer example. I can think of a customer that uses Datadog. Their SRE team uses Datadog for observability, full stack observability, and all that. Their developers hate Datadog because they think it's really complicated to use and makes it really difficult. And they just want to be able to get into logs and search quickly. And so then they use our log management tool because we essentially, the way the indexing works, we index everything and it's quick and it's really easy to search and all that kind of stuff. Great. SREs are also doing some different things around service level objectives. And they've got a separate dashboard for that. And so the Mezmo pipeline feeds everything into Datadog. It also carves out metrics, translates some log lines into metrics, and feeds it to their SLO dashboard. It also then carves out the stuff that the developers want and feeds it to log management, the Mezmo log management for them to look at there. So pipeline is way more than just an OTel collector on steroids. It's doing a fair bit of a lot of different things in terms of not just grabbing the data, but formatting, redirecting, and all of that, and feeding lots of different sources. But look at it and it's like, if not a lot of different sources, then maybe what you get in Datadog is enough.
I like the imagery of it, but I fully agree that it falls short to describe it as just an hotel on steroids. One thing that I would add on the Datadog specific, I'd be remiss not to bring up in this case of indexing and putting to archiving. Most systems that Datadog, Splunk, all these, they will still charge you for that initial ingest. Whether you choose to index and put into your archiving or any other situation, there's still a fee associated with that decision within Datadog. Putting something like a Mezmo pipeline up front allows you to remove that initial cost and make those same decisions for pennies on the dollar.
Awesome. Well, guys, this has been great. Where can people go to learn more about Mezmo?
Best thing to do is go to Mezmo.com and click on Start Free Trial and help yourself to the whole platform.
Nice. Well, thanks so much for joining us today, guys, and for everyone who's watching. We hope you found it super informative. But once again, thanks for joining Mezmo and D-Zone. Best of luck on your journey toward better optimization.
Thanks, Corey. Thanks, everybody. Really
appreciate it, man. Have a good day.
Bye.